The last speaker is Robert Iasky.
What I'll be presenting is the mappings that we've been doing in the sedimentary basin in WA, and the maps that we've completed. And also, it's important to note that the mapping, because of the wide range mapping that we've been doing over the whole basin, the mapping is regional and not detailed. And then I will also be showing 3 examples of traps, which are probably the most interesting part. These are the sedimentary basins that we've been mapping in WA. The backdrop you might recognise is coming from GeoView, and it's a wonderful resource. So these basins essentially are the areas where petroleum companies have carried out petroleum exploration and have produced the large volumes of data, and this is where we've concentrated our mapping. And the primary data sets that we've used are seismic and deep wells. The wells that we're interested in are typically greater than 1,000 metres, and some of the mineral people here might think that 1,000 metres is really deep, but in petroleum exploration 1,000 is a shallow well. And the reason is that the sedimentary basins are thousands of metres thick, and our targets are also greater than 1,000 metres, typically 2,000, 3,000 metres in some instances. Okay, I've mentioned seismic data. This is an example of the data that we use, and on the left-hand side there's 2D seismic data, there's 6 lines, and on the right-hand side there's 3D seismic volume. The vertical scale is in two-way travel time, and this is typically the data that's submitted to the department. We don't get much depth data, although some of it is becoming more popular these days with faster computers. It's not there yet. One of the things that we need to do when we do seismic interpretation, we need well data with well velocity surveys, which enable us to correlate seismic stratigraphy. You might notice some of the wiggles on those seismic lines, and one of the issues is to try and understand what those means in depth. Where do they lie with regards to the stratigraphy? The velocity data from the deep wells is what we need to capture in order to correlate time to depth. So on the left-hand side, you can see the basins that we've been interpreting and the number of wells that we've captured with velocity data. That's quite extensive. This data has not been made available to the public yet and will be. On the right-hand side is an example of the data that we're capturing, and specifically there's the measured depth and the one-way time, which is the original data that is recorded when we capture it. I'll just cycle through some of the basins very quickly just to show the volume of data that we have in each basin. In the Perth Basin, we can see there's a lot of wells. A lot of them are offshore actually, and there's extensive 2D data and some 3D data, most of it again offshore. The other surveys include electromagnetic, gravity, magnetic surveys, and some geochem. So we'll just cycle through some of the data. See, there's a lot of data in the Perth Basin, not a lot of data in the Carnarvon Basin. Even though it says 96 wells, only 27 of those wells are deep enough to be of value. And there's 78 2D surveys. Sounds like a lot, but most of it is up in the Rough Range area and the Merling-Lay Basin. Northern Carnarvon Basin, a stack of data, but most of it in state waters. You can see the area that we're mapping. It's delineated in the red line. The large number of wells, nearly 900 of those on Barrow Island. All of the 3D surveys are offshore. Most of them just cut into the state waters, but most of them are actually outside the state waters. Canning Basin, very large area. Not a lot of data in the southern Canning Basin, which we've finished mapping. A lot of data in the northern part. Officer Basin, very little data. 22 DD surveys and only 9 wells that are worth talking about in terms of correlating the stratigraphy with the seismic. All right, so now what I'll do is I'll just cycle through the basins that we've completed, some of the mapping, again in a clockwise direction starting from the Perth Basin. You can see on the right is the stratigraphy of the basin, and the red arrows indicate the stratigraphic units that we've mapped. Not all of these units are mapped throughout the basin because they're absent in some areas. These are the mapping in the Perth Basin. And what you can notice is a big gap in Perth. And the reason for that is that we've got no data. We never recorded any seismic surveys, and there are no wells except maybe some shallow water wells. I've only picked 4 of the horizon just to give you a flavour of the mapping that we've done. And the other reason is I've picked these 4 horizons is that they actually go through both the north and southern Perth Basin. In the Canning Basin, we've mapped 13 horizons, and we've not all of the stratigraphic horizons range through the whole basin. This project in the Canning has been going on for a while, and before the CCS project. So these are some of the maps that you can see, and you notice to the north we've completed some of the mapping on the Leonard Shelf. Officer Basin, we've mapped 6 horizons throughout the basin. The stratigraphy is pretty consistent right through the basin, which is handy, so we can map the whole thing. And these are example of 4 maps. The Table Hill Volcanics, the reason you can see the break is that the Table Hill Volcanics actually is absent to the north. That's on the right, the map on the right hand side. I'll go through 3 examples of possible traps. I'll start off with the Perth Basin. That's the Yadarina field. For some of you might not remember, this field was drilled in 1964. It was the first oil field that was found in WA. It's now depleted. It's the structure. If you look at the Yadarina well, Yadarina 1, you can see a nice red line that goes right to the bottom. That well is about 2,400 metres deep. And I think from memory the time, so let me describe what's on the slide. On the right hand side you've got a depth map at the top of the Permian, and that's roughly the middle blue horizon that you can see there, and the field is in the Dongra sandstone, so that's on the lower part of the well below the fault. So that's a tilted fault block closure. We've done some work on that, and it's actually a strong contender for storage for manufactured hydrogen. Canning Basin, I thought this was an interesting example. The Sundown field, this was the second oil field found in the Canning Basin, and the field, the reservoir was actually in the ground group, which is between the green horizon, the dark green horizon, and the dark blue horizon. And you can see it's a nice rollover onto a reverse fault, and the fault has only got minor throw on it. But if you go deeper, you can see that the fault actually is normal at basement level, and it's the reverse movement occurred during the Fitzroy movement in the mid-Jurassic. Now, that's a possible contender, maybe, but the interesting thing about this field is that it's sort of to the southeast of Mida where we had strong hydrogen recorded. Unfortunately, they weren't geared up to record hydrogen when they drilled this well in 1982. And this is a final example in the Officer Basin, where it's a beautiful reverse fault, and we're looking at the Bolgio group, which is essentially all of the stratigraphy below the blue horizon, and we're looking at interbedded reservoirs, sort of stacked reservoir, where we've got shales overlaying sandstones. And there's quite a few of these. The good thing about the Officer Basin is that we've got a lot of salt, so there's a lot of salt diaparism in the Officer Basin, and there might be some salt movement there as well in this section. And finally, I think this is just a repetition of Deirdre's slide, and this is where you can find the maps. And if you click on the plus sign over to the left-hand side on one of the data sets, it will get blown up into, and you can see in the green, you can actually download the maps that we've made available. Thank you.